Good evening, everyone. I was asked to talk about how Kiwi Bank predicted LTV for Sovist in reality, and also we will discuss top 3 best solutions. Okay. Now I will tell you about how we build the LTV prediction model. Then finalists will tell us their solutions. And then we will have Q&A section, maybe panel discussion where you can share your ideas about shakeup and your pains about hacking the metric, and where you can ask your questions to organizers and to each other. Okay. In 2000, it's our action plan. In 2017, Kiwi launched Project Sovist, but de facto and de jure, these are 2 different businesses, Kiwi Bank and Kiwi. Employees even located in different offices in 2 different buildings. The size of Kiwi is bigger than Sovist, so we have a big data department team with dozens of people, and we have a business modeling group where I work. Our group consists of 9 people, and we solve various complex tasks in machine learning, in financial modeling, even time series forecasting, and ad hoc requests from C-level managers. And I find it difficult to remember what initiate this project. I mean LTV forecast for service. But at some point, we start to calculate the lifetime value of the Sovist's clients. For this purpose, we collected the main income and expenditure items. And since not all of you working in banks, and the product of Sovist is different from classic banking, let me show you about this. Evgeny, turn off your microphone, please. Thank you. From client side, it's simple. Client buys some goods from one of the various partners of Sovist, and there are different categories from clothing to air tickets. And Sovist pays money to the partner immediately. After that, client pays back money to Sovist in equal parts for the next 3, 5, or 10 months. So it's installment. The main difference from a regular credit is that there is 0 interest rate. The economy of the product is follows. We have expenditures and revenues. Expenditures can be, first of all, cost of customer acquisition. Second, it's scoring costs, because we don't want to give installment for a person who will buy TV for $1,000 and wouldn't return. Third, it's transaction-based costs for providing transactions by Visa or MasterCard. It's cost of clearing, authorization, and dozen other items. Next is marketing costs. It's cashbacks or other bonuses for clients. And there are some non-transaction based costs. Revenues consist of commission from partners for attracting customers. Partners give us money for the customers we attract to them. We also get interchange. Without going deep to the banking details, this is the money bank can be paid if our customers buy something using card. So Visa and MasterCard set a different amount of reward depending on the merchant category. For example, if client buy something in restaurant or in groceries, it will be different. And in restaurants, interchange is more than in groceries. And in another revenue item is paid options in Sovist. For example, in Sovist, clients have an ability to increase installment duration from basic 3 months to 10 months. When we put together the target, business modeling group, we make different analytics, and we even build ML models. For example, we show to the customers how to our managers how much money we lose on the clients who received the card but then did not use it. Perhaps a person was thrown a card in a shopping bag, or perhaps a sales agent gave him a card at a shopping center, for example, but then a person come home and changed his mind. These clients should be either predicted and not given a card, or they should be more involved in the product. For example, we should offer them big welcome bonuses for the first transaction. It turned out that there are a lot of people that we could easily predict their lifetime value. For example, if a person already has a credit card with a large credit line, there is a huge probability that they will get paid with their usual credit card and will not pay with Sovist card. For various reasons, we didn't have time to bring this ML model to production before the company Sovist was sold. However, we managed to do a lot of different analytics on LTV. I remember the moment when we made a dashboard on LTV in Tableau, and we discussed it with the guys from Sovist. Within an hour together, we saw a large number of insights, and after that, they said they get ideas for next 6 months of work. And we also made a set of simple manual rules that can be quickly implemented in production to the scoring system based on software from SaaS. To do this, we tuned shallow decision tree, simple decision tree from Sklearn, which of course did not perform as cool as full-fledged gradient boosting, but also normal. Not perfect, but okay. As for the quality of our full model, which determine profitable and unprofitable clients, we received a good division of classes and AUK in the region of 85. The good quality is due to a much more diverse sources that you see in the competition. In the competition, you probably noticed that many fields was heavily anonymized, obfuscated, transformed, and divided into categories. This is all due to information security. Also, to avoid the disclosure of the ratio of profitable and unprofitable clients, we mixed approximately equal parts of each class. Initially, the classic raw AUK metric was planned, but the competition organizers asked us to come up with something more interesting. And then I created 4 or 5 metrics. For example, one penalized more false positives and less false negatives. Another was tried to tie cost of customer acquisition on different channels. But in the end, AUG at K was got into the competition. But this metric is just my theoretical thoughts and not a real business practice of Kiwi. My idea was that we can have an impact on a limited number of cards, for example, 10%. So we wanted to have as many good cards among them as possible. At the same time, we are not interested in the sorting other samples. As we understand, at competitions, participants should only think about maximizing the metric in any available ways. So after the competition starts, participants write to us that the metric could be manipulated. For example, we can send a pair of confident ones and a pair of zeros and nullify, set to 0 the gray zone between them. Or you can send a lot of confident ones and a single confident 0 and to the checking system, and these heuristics can give you AUG at 85 plus. I think the winning team will tell us how they cooked their solution with score more than 91. Without going deep into details of hacking the metric, let me explain a little this. Participants could send any 10% of test data they wanted. And to maximize quality, you only had to send the people you are most confident in. For example, you could send 5% super bad, 5% super good objects, or 4% and 6%. This ratio could be selected via cross-validation. And Lydia Khramova and I, we discussed this point and decided that in any case, participants will have to tune ML algorithms and give for this 10% perfect separation for that 10%. This means that task does not lose its relevance